Let's start. Let's start with the new topic today. As usual, the recap is like this. We have studied, I think, for 4 days the assembly related APIs, assembly related examples we have seen, and yesterday as well we have seen some examples in uh, in assembly, and those are related to arrangements and how we can access the features or datums of a component via its prototype. So just to add uh, to your knowledge about different APIs in assemblies, we have gone through that topics. Now, before we move on to drawings, I would like to keep today's session a little bit on different topics, which not certainly fall on very specific ones either in assembly or in drawings or part, but they are again very useful ones, and they cut across actually. They cut across these different things. And what I'm talking about is mainly the objects, the common objects which are there that we deal with when we work with uh, with the APIs of NX Open. So I'm talking about NX objects. I'm talking about displayable objects. I'm talking about tagged objects. So all these are the kind of objects that they actually cut across this. So I would call today's uh, session as a assorted topics, because here not specific related to drawings or assemblies we are learning, but we are trying to see these objects and how we access these objects mainly, because once you know how to access them, then you get more understanding about them, of course, but you also then can deal with them based on which situation you are trying to handle with whatever you are doing in future when you try to develop your own programs. So that time is this knowledge is definitely helpful, because we it is there are APIs, there are programs, there are references that you do have, but it always starts with uh, what is the starting point. So once you got something in your mind that whether you can create a program for this task, you can create an automation for this task, or if you got anything of this input for yourself, you got an idea for yourself that you can start developing a code around this area, around this automation idea. And when you start, defining a starting point is very important, and that starting point, I think, it is only limited. uh, uh, your knowledge of programming is definitely will be helpful there, but it is going to be less helpful than using a common sense, or than using the your knowledge of domain, your knowledge of CAD, and your knowledge of using some features within CAD efficiently, because that will drive how you start your programming, how you approach developing that requirement. And there, more important is your understanding, your common sense about the topic, your understanding about design engineering, your understanding about that process, your understanding about CAD software is more important than a programming and APIs. Programming and APIs comes later stage, or it will help you in detailing stage, but how you approach that program, that will uh, that is another part of story, I would say, in short. And these different object types that we will be seeing today, that will help you in navigation. For example, before I start, let me share the yesterday's example. So how we did it, we have first fetched the component using for each loop. on root component we do have that loop, and we fetch the component. Then from component we fetch the prototype. So from prototype we got the access to the part class or the APIs within part class for that component. Now within that component, what I did, I gone and used uh, owned component assembly. I think I use component assembly within the part class to see the component assembly object or to get the component assembly object, and then I again use some API to fetch the arrangement. So you can see how we are flowing. So it is data flow. So how the data is flowing or how we have a step by step going to arrangements is actually we are taking a long route to go there, because eventually we landed in component assembly and then we fetched arrangements. But the other way to do the same is we don't need to get into the part class or the part object of a component. We don't even need to get the prototype, because we can straight away get we straight away have component assembly, because we are working in assembly and we do write those two lines extra in our template code. If you remember, one is component assembly itself and another is root component. So we do have access to these two uh, uh, objects already, and we can directly access the arrangements from there. Then why we need that long route to get there? So it is again case to case basis. There is nothing right or wrong in these both options that we tried, but based on what exactly we wanted to do, we can use any of these this method. For example, uh, I wanted to uh, access component assembly or the owning component for that part for some reason, because I would like to start from part, because I would like to find out the part, the information linked to that part via component assembly, something like that. Then that long route is a relevant one for that situation, for that case to handle. Otherwise, we can straight away use the arrangement within component assembly. So this is, but as we know that this is the inheritance nature of these objects. This means there are many things which are interlinked, and as you understand this interlinking more and more, then you can use this understanding in defining approach of your program. So when you write your own programs, this understanding will help you get the uh, get the approach right for your requirement. Now if I tell you one more example, uh, we can get the bodies uh, via features, or we can even get the features from body. Vice versa, it is possible. Another example is we can get the bodies or even features from drawing view. We can even get the component name from a drawing view, and we can even get uh, the parent view from a projected view. So uh, this is all links in between different kind of objects. So if we know that uh, edges belongs to bodies, if we know that faces belongs to bodies, if we know that bodies belongs to the component or part, or bodies are made of body feature. So if we know that this is the interrelationship at CAD level, then we can use that understanding in understanding of these objects in NX Open at NX Open level. So this is a little bit a deeper topic actually. I do not wanted to touch that deep today, but I gone with the flow and touched upon this topic. But this is very broad, but this is conceptual. If you understand at least at conceptual level, this you can recall at when you develop your own program, and it will help. So uh, though we are going through this approach, that parts and then assemblies and then drawings, but there are some topics which actually cut across all of this, and we are going to study few of them today. I won't say everything we will cover in today's session, but we'll try to touch upon at least a few of them today. Okay, so enough about the background, the theory part of it. Now let's get into the action. So this one is typical part. As you can see, it is actually there is no meaning to this geometry at all. I just pick up some random things that I do have, because we are no really bother about whether it is a useful uh, geometry, meaningful geometry you see in a part model. Uh, but it is just for a representation purpose or just for the reference that we are using. And what I want to show you in this example is uh, is this information. Now maybe you have already seen this example. I think we have picked some of the I think similar example, or maybe I'm not sure, maybe the exact one. But we are going to study the same thing with another perspective today. So you could see here I do got points, lines, body, then face, edge, and again faces, edges, lot of them there. Displayable object, even sketch, faceted body. These are the constraints. I think most of them are in a sketch. So these are sketch relevant objects, constraints we do have. So these are different things that we can see. Those are available, or these are different objects that we can see are available into this part. Okay. Now let's see this example. We will see this example not here, but in Visual Studio. I can copy this code from here, and we will see that into Visual Studio. Okay. Now I think I need some cleanup here. I do not want you to bother with too many details. We don't need the mark ID, that is for sure. I will keep this for now, not much of important. Even this is not really required, but I will still explain this to you so that you get what it is. But before that, let's focus on the core part of this. So this is actually NX objects. So if I recall what we have studied about NX object, if I recall this thing, so in NX API guide, NX remoteable object, NX object is something here we can find, but which is very common and generic type of object. Generic means there are most of the objects which are actually NX objects. Let's see if I found it in tagged object. NX object. Okay, we'll try to find here. NX object class. Okay, so it is here. It is under tagged object. Okay, so we are going to see tagged object, NX object, and maybe displayable object as well. So if you see from this list, this is actually very long list of objects. And by this time, you already understand that there is lot of types of objects, and they create lot of confusion. They create lot of mess. They create lot of complexity for you, because this is something that keeps you bothering when you are learning. So even if you learned it, even if you are uh, learning it for 6 months, this will keep you bothering. So this is how it is. We cannot do much with that. But what we can understand from this, there is huge list of different types of objects. Those classify under annex object. So it is very huge list. Okay, even we do have displayable objects here, which is a kind of a focus area in today's session even. But you can see this is huge. Okay, huge list. So what we can understand from this huge list is, at least there are lot of types of objects. They fall under NX objects. In short, in summary, there is everything, most of the things that we deal with, or even 99.999%, whatever we will deal with, the different objects, uh, those can fall under this category and called NX object. Now, I'm coming back to my own example in NX. So I can only, so this you can see once I actually, let's rerun this. Okay. Uh, yeah. So I have, let's rerun this journal. Okay. Now you see, this is the huge list though, but this list is only reporting the objects which are found in that part. But when we say the same next object, it is actually huge list in the API guide. So maybe there are only few things available here. Of course, there are only few objects available here, and that's why we see those objects here. We can't see all of them. But uh, but still there are a lot of objects. Those can be classified into NX object. Now, if I run this in this another part, this one is drawing. I will again empty this information window and we'll try to run this here. Now you can see uh, as I'm into drawing mode. Okay, so most obviously what I would imagine is that I will get more objects like annotation, dimension, note, drawing view, label, this kind of objects. But here you can see I even get points, line, arc, center marks, center line 3D. This is something understandable and we can understood because this is drawing. But we even get lines and arcs here. We even get dimensions. It's there. That is perfectly fine. We also get faces, edges, uh, displayable objects, drafting body. So maybe this is something that you don't know when you work as a design engineer. Drafting body, you only know something called body. Faces, edges, up to that it is fine. Again, there is something called stepped section line. I even don't know what is this. I haven't come across this. And there are lot of sketch constraints. So you can see, though it is a drawing, it has still found the uh, the source of this drawing views, which is of course the part itself, the bodies, the faces, the even the features. Those are used for creating this drawing view, and even then the bodies and those sketches as well as sketch constraints even. So we got lot of these objects. So these all objects actually classify under NX object. Now, my focus is not to write the code in front of you and try to link the connection from that code line to the API guide and tell you that this is something coming from this specific class or this specific namespace and how we can use that, because we have done so far of that so far. So I am trying to give you the same example, understanding of that with some different perspective. So why actually this might have been used NX object? The one thing could be that there are everything that that is used, that is created in that part, assembly or drawing, whatever. So that mostly falls into NX object. Then, if we are not sure which object type, we have to do the for loop. So that time it makes sense that we do a for loop on NX object. We are not sure which object we exactly need to go through. That time we can start with NX object. And NX object is also supported by this API. So under work part, this layers class, there is get all objects on layer. So we can specify the layers here. uh, you can see I have specified one layer number one, which is default layer. So if you are not uh, segregating your objects into different layers, then it means that all of your objects reside in layer number one, because that is the default layer in Unix. So so it is actually returning all objects in that specified layer. But if you see the IntelliSense, it is also mentioning that you get all these objects in NX object. So you get this as NX object. So that is why NX object is used. So this is here we got couple of reasons to use NX object, because this specific API only returns NX object, and we for some reason don't know which objects we need to fetch the information for. So that's why it is NX object. This is the NX object variable we have declared. And of course, as this API itself suggests that it is a square bracket after the type of object. So that is why it is used that square bracket. And you know that the meaning of square bracket. Square bracket means array, because it is going to return me the bunch of those different objects. Now, one more perspective or one more angle to this. So far, what I have said to you is that about the collection, whether it is face collection, body collection, feature collection, all of this kind of collection. And we have also seen in arrays that arrays are actually can store the several objects of of same type, not similar, of same type. Uh, so we can use that when we are dealing with more than one objects. So it is if I have even given you the example of one is fruit, and that is either string or integer, let's say. But now I wanted to deal with multiple of those strings or multiple of those integers. Then I am using the basket. So that is basket of fruits or basket of string objects or basket of integer objects. So if I tell you this way, you understand that it is only one specific type, but there are several numbers of that. Those can be stored into a string. But what we have seen now here, it is NX object. It is actually the type of object that can store several types of objects. This means this is the array, that is for sure. But this array, this array basket is now holding different types of objects together. So this is another power of NX object. Maybe most of the times you won't come across NX object in your case, because it is very broad level, because it is very generic level. And if you wanted to use specific APIs, for example, uh, get length. Get length you are using in case of curves, right? You will not use get length in case of feature. In case of feature, you will use something else. You will either use get name of feature. You will either use whether it is a body feature or not, whether it is suppressed feature or not, whether there are expressions associated to that feature. So every object wise, what parameters, what properties we deal with, that change, and that change with every different object that we deal with. But here we are getting an opportunity to collect all those different kinds of objects in just one basket. And then its use case can be, actually there could be several use cases. I'm not coming across any specific now, but there could be several use cases of this. So this is another perspective of NX object. Now, let's come to the for each loop. Now, so far, what we have done, we have seen for each loop for, I think bodies we have seen. We have seen many for each loops for component. We have seen it for features, I think. So these all for each loop examples that we have seen so far, those are specific, those are for specific object types. And the framework for each is very straightforward. What we do is we access the each element of the collection of objects. The same thing is happening here. The only difference is that we do have the collection of objects which is very broad, and that is why it has all of those different kinds of objects together. It is holding all those different kinds of objects together in the same basket. Now we have seen all of these objects already. We have run that example in couple of parts. So we saw that what different kind of objects it reports or it captures. And we have seen the huge list which is already there in NX object class, under NX object class in the API guide. Now the beauty of this for each loop is whether we find 100 objects, whether we find 200, 1000 objects, we do have access to all those different kinds of objects through this for each loop, because my NX object array contains lot of those different objects, and that is again in a number, that is a huge number. Now what is done here, it is again the simple thing which is listed inside the body of for each loop. We are just trying to get the type of the object. So this is the get type object, and this is again uh, we are doing it on each element. So I am calling that as obj. So each object in this collection, we have named that as obj, and it is also defined as NX object, because I'm uh, looping the NX object array, and I must name it same object type. You have not seen me using some other type which is very different from the collection of the objects, because if I try to do that, my program is going to give me the error. Let's say if I try here something else like tagged object. It is, I think, not giving me any error, but maybe it will produce an error while we uh, debug it. Maybe not, but I will confirm that. Okay, but mostly what we do is we will name the same object type which is relevant to the collection that we are looping. Okay, now as it is broader and contains lot of object types there, then it then we can use this get type API. this gets the API of that current instance. Current instance means the object itself. So this way, we are actually finding out the type of all those objects. Now, if I wanted to get to the specific type, so this is the if used inside. Now, if I wanted to use the specific type, let's say only body. Now, I will comment this line, and I'm only interested in knowing about the body. So what I can do is I can have the if function like this. So obj is nxOpen.body. Then I can write that body object found. Or I can just write it like this, body found. I can write something just before this. For example, obj dot name, which is, I think name is not possible. Obj dot, I can write something about that. Let's say tag. We'll understand what is tag also, but let's say tag, and then plus sign for concatenation, and that's it. Let's say I wanted to only report the bodies from that basket, which holds all the several types of objects. So I can have this filter inside for each loop, which will find the specific object type for me. Now uh, again going back to NX object, uh, in terms of use case or in terms of why NX object is, when you are not very sure about which kind of where you will find the required object type, then you can straight away go with this line which collects all the different types of objects, and then you write a for each loop, and then from that all that collection, that can be a garbage for you. Maybe this line finds out hundreds of objects from your part or assembly, and you are only looking for one or two of them which are relevant for you, but you don't know how to access that specific object. So that time you start with NX object, and then you start with for each, and then you start with writing some kind of filter like this. So this is a filter actually. This is if condition which only bothering about the body type of objects. So you are starting from a very broad uh, thing which is NX object. You are starting from very broad level, but you are narrowing down to specific thing that you are looking for. So let me copy this and try. Now you see we have only found one body into this entire set of objects that we have. Now if I go to this another part and try it one more time, now I found three bodies here. Okay, so now again going back to the example. Now this is a typical example where we wanted to fetch some information, fetch some objects. We started from very broad level, NX object, and we narrow it down using if condition within for each function. So this is one way. This way will help you when you don't know which for each loop will help you. let's say I wanted to, uh, what I know is, let's say I will write another for each loop for you. For each, then into bracket, line as ln inside in work part dot lines. So you can see it returns the line connection. It means it returns all the line objects in that part. Very simple to get all the line objects, right? Bodies, even. Very simple to get the bodies. It is also very simple to get the faceted bodies. Now I want constraints, let's say. So I do have displayable constraints as well. So it returns the displayed constraint collection belongs to this part. Again, very good. Now I want to get the features, let's say. Features. Good. I do have features as well. Now let's say I wanted to have what else? Expressions. Okay, expressions are also there. So very good. Let's say I am looking to get the views. The views are also there. So you name it and you do have the specific collection of that objects available within work part. Now I am trying to find out which is the object type that I typically won't find through this method through the work part. Let's say units. Units also I found. It is okay. Planes. Okay, planes is also there. So lot of object collections are already there, and this simple for each loop will help you get the access to that. Now, what is else? I think I will not get from work part. Constraint even I am getting now. WCS. Yes, WCS is also there. I can even get the WCS objects. Tagged object. I don't get the tagged object from here. Uh, it is only the tag of work part that I'm getting. I'm not getting all the object tags from here. Uh, what I will not get from here is, okay, let's say sketch feature. Okay, so it will return sketches as well. So sketch feature also it returns. Let's say I want specific type of feature. Now I am not getting the much relevant example. So I'm landing on this only. So there are features we get, right? But I want to get the body features. Let's say if I get the body feature even here. Now bodies I do get, but I do not get the body features. Now let's say I'm interested in finding out the body features. So what I can do is I can have the for each loop like this. I have to name it as feature. Mm, okay, something I'm missing out. Okay, but I think I can leave it like this. But let's try. Next, open dot features. Yeah. Okay. So I want to access the body features because I'm not getting the body feature directly from work part. So I get a broader level object, which is features in this case. And this is then this is the similar case like this, where I need to use the filter like this to to only get the objects which are body features. So similar to body features, I can even look for let's say whole feature, or I can look for the pattern features. So I'm looking to get some specific type of feature, but I do not have any method or any API within workpart to directly access that object type. So in that case, I will use something like this, which is called the broader methods, which is similar to this. So what I'm focusing on, if you're not yet following me, so what I'm focusing on getting the specific type of object that we are looking for so that we can fetch some additional information or some specific information about that object. So we can only fetch the specific information about that object when we able to access that object, right? Unless we access that object, we won't be able to fetch the properties of that object. So here we will write a condition, sorry, condition filter using if. So filter using if for further specific object finding. So this is how we can do. So this is broader way when we don't have any direct method to access. We do have many direct methods to access from work part, but if we do not have that, then this is the way that helps NX object. So this is where you can understand the importance of NX object. Now coming to the tagged object, which is the next point to discuss. Uh, I want to discuss today. Now, tagged object is next object we have seen. We have discussed a lot about that. Now, tagged object is also similar. So when you talk about the variety, so NX object do have a lot of variety. It can store a lot of different types of objects. Similarly, also tagged object can do the same. Now, let's see tagged object in a API guide. So tagged objects are actually hierarchy wise, they are one level up NX object. It means NX object are tagged objects. It means all NX objects are tagged objects. And uh, vice versa, other way around is not all tagged objects are NX objects because there are other kind of objects as well which are categorized as tagged object, and NX object is just one of that. So you can see that NX tagged object is much more broader than NX object, but maybe we don't know the API to scan all the tagged objects because this specific API which works on layers which returns all NX objects. We don't know which API to use to return all the tagged objects. Maybe there is API, maybe there is no API for returning or collecting all the tagged objects. So that is, we don't know. So, but tagged object is much more broader than NX object. Now, where you will use tagged object? So all the cases like this, what I have explained so far about NX objects, the same applies to tagged object as well. So in all the cases, similar to NX object, you can use tagged object. Now what is difference? Now why it is called tagged object? Actually, there is a reason why it is called tagged object. If you see this dot tag, that I have used. So this dot tag is actually a tag or similar to barcode, you can say. Give me a minute. Yeah, so tagged object is actually all the objects which have a tag, and almost every object in Annex do have a tag. Now, why they have used tag, actually, we don't need to get into that. But one thing I can tell you from my uh, understanding is that there is a barcode or there is a number assigned to each object in NX, and that object that number is always unique. So maybe this is their way of uh, naming or giving some unique identification to all the objects so that they won't end up in some kind of duplication at all. That is why they have created tagged object. If you give, if I show you my result, this journal result in NX, you can see this is the number. This is a 5-digit integer number, and this is called tag. So all the objects in the uh, NX do have a tag. Mostly all of them do have a tag, and this tag is always unique. So this is the beauty of tagged objects. Now, if you let's say if you are working on some logic where you want to compare two objects. For example, let's say I'm trying to create some hypothetical example. Let's say you do have the part, the geometry like this. Now you have given a task to uh, compare the faces and find out the faces uh, based on some logic. Now I'm thinking what can be that logic is uh, okay. Now let's see if you wanted to compare two faces and find out if they are having same area. So if I, let's say this face, I wanted to only select faces. I do not have that option. Okay, but you can understand. So there are four faces like this on this body, which do have similar area. Now you wanted to compare the faces in a such a way that you wanted to find out the similar area faces from other bodies, not the same body. Or you wanted to make sure that you are comparing one face with another face and you are not comparing the same face. Yeah, so this is the good example, I think. Let's let's hide other. Let's delete to make it simple. Okay. Now we do have only this body. So this cube we do have. Now uh, you wanted to write the program where you are comparing two different faces and you are finding out some common or some difference between them. Now what you will do is maybe you will write two for each loops, and you will pick one object and you will pick another object and you will compare. Now you wanted to compare that and you don't want, or you wanted to make sure that you are not comparing the same face with the same face. So means you are not comparing the same faces. So that time this tagged object will help you. Now why you are comparing, maybe I am not good at giving the example right now, but just assume that you are comparing it for some reason. Now tagged object will help you to find out whether these both objects are same or not. Means if you write a logic uh, to compare them with area, maybe you will find all of these faces they do share the same area, because every face is same. It is a cube. All sides are same. So every face you will have the same area. Now how you will find uniqueness? So you will only find the uniqueness via tagged object. So let's do some modification into this. Okay, let's do this as face, and if it is face, let's say we will write it as face. Okay, now let's see if I do get the area as well. There is only get type. Okay, now why I'm okay, so let me first. So I wanted to get the area of a face, but I do not have that API here. So because OPJ is my face object, and if I go and search for area, I want to get any API. I'm little bit diverting, but let's spend couple of minutes here. Let's see the face class. If I do have the area API, find area. I think I do not have it here. So okay, so leave it. Don't wanted to get into that if it is not that easy. But I am getting all the tags at least. Now I can go and run this code. Expression expected. I can see I got these many faces. So these are ideally should be six. Yeah, they are six. And you can see they do have different ID, different tag, and there is no duplicate number here. So this is called tag. Now, if I would have found the API for uh, fetching the area information of this face, then I would have found that there is same area for all of them because it is cube, but still they are different tags. So different tag number all of them have. Now let's see if I do change this again. Instead of face, let's see if I do age. And here as well, I will change as age and try this again. edge. Now you could see I have found the edges, but again you will find that there is no unique, sorry, there is no duplicate tag. All of these are different. Even the tags of edge will not match with tags of face. Even this will not match with tags of feature or body. Every tag will be unique. And if you are like creating some logic where you want to confirm the uniqueness of the objects, tags will be useful. Now if I now go and slightly modify the code further, I think it's easy to get uh, the length of this. If you write the what you can say, if you write one more line and get the length of the edge, you will get the length of edge, and you will find that it is all equal. Maybe I can try that quickly. Of course I won't get that here, because this is not the edge uh, variable. Actually we are only checking if it is edge type, but actually it is a tagged object, and we have to convert this object into the edge to access the edge class. So this is we have to do to, and then only we will able to get the length. But that is I will not get into now, because that's not the topic for today. So this is about the tagged objects, which is little bit broader than NX object. Now, one thing I can again talk is about displayable object, but I will talk about that only theoretically through API guide. We will not see the example. Here, if you see this uh, displayable object, it is actually hierarchy wise, it is just below NX object. It means uh, this is again very specific one, displayable object. So it again means that all displayable objects are tagged objects. All NX objects are also, sorry, all displayable objects are also NX objects. And let's see what is there in displayable object. So we have already know this actually, but these all are displayable objects. And what we mainly deal with are, it can be annotation, it can be dimension, it can be the axis, the plane, edge, face, body. So all of these are actually sketch, even a sketch constraint. So all of these are actually displayable objects. Displayable objects meaning all the objects that we can see in the graphics area. I will try to attempt if it is simple. NX object dot displayable object. Yeah, I do have a class. I can add a filter like this. So let's have it. Now I do have this line. Okay, and then what I will do is I will write one more line, one more uh, addition here onto this string. What I will do is obj dot get type. So get types returns the type of that object. Yeah. So I am now checking that if it is displayable object, I am reporting its tag and it is its type. So this way we know what are different types of displayable objects in our part. Let's see this into NX. Again, I'm missing this curly bracket. Now you could see we do have these many displayable objects into our part, starting from point, line, body, face, edge. Now this is something we have to uh, see, because it is displayable object, but we don't get the specific type of that from here. Faceted bodies, constraints do we got? A lot of objects are there. Again, one thing to note: this will never match. This will be always unique, always unique. So this is tag, and these are different displayable objects we do have. Now, last thing only. Let's see. Let's run the same code on this drawing. Let's see what it returns. It has returned the drawing related items as well, like center mark, center 3D, note, label, hatch as well, dimensions as well. So these are also the object types which are visible in a drawing, and those, that is why those are also displayable type. Now this is the these are the common not yeah these are common actually. These are the object types that will cut across any automation that you will do, whether it is part, whether it is assembly, whether it is drawing, and those are actually broad in nature. And I tried to explain my level best what could be the scenario or case where those are useful. Definitely, those are useful, but case to case basis, it differs a lot. And no, uh, we don't know, but where it can be useful for you going forward. So maybe these are going to be useful definitely. We don't see them in action most of the times, but that may be the starting point for you in most of the cases going forward. So this is about these typical types of objects or category of the objects: displayable object, NX object, and tagged object. We don't need to go uh, on top beyond this. We can stay just below the tagged objects. We don't need to see these ones because these are again much broader in terms, and we don't really get into that in most of the cases. So we can simply ignore them. But this is what is the relation between tagged object, NX object, and displayable object, as well as we have tried to see the significance of them into our program. So this is all for today. I think you got it, and you'll able to use it whenever you are in need of using this kind of objects.